Now we discuss the next topic, that is the God particle. Why this is in news? Because Peter Higgs, a known scientist who was responsible or who was the man behind discovering this God particle, has died. Now there were predictions about this Higgs Boson particle, it is also called as, since the 1960s. But it was only in 2012 when the Large Hadron Collider, this huge machine which was installed in Europe, was able to scientifically identify this particle. The significance of this particle is that it gives mass to other fundamental particles in at the subatomic level. This is also a subatomic particle responsible for giving mass to the other particles. The other particles do not have mass in itself. It is due to the interaction of those particles with this particle which gives them mass. The more the interaction, the more the mass they will gain. This is the science behind that. Now, let us get started with this, that why this is in news, because physicist Mr. Peter Higgs has passed away, and he was the man after whom the particle Higgs boson is named. Peter Higgs died on Tuesday, that is April 9, aged 94. Now, his story a little bit, we should know that he was an extremely shy personality. Extremely shy personality means he was not using a cell phone, was not using a laptop or a computer. The only way to communicate with him was his landline. And in 2013, when the Nobel Prize was announced in his name, and those people generally from the Nobel Prize committee, they contact the person whom they are awarding this half an hour before or before awarding that prize, but they were not able to reach him because he was not home. He was somewhere outside and meeting his friend or some of his cousin, and they delayed the ceremony also by half an hour, but they were not able to reach him, so they announced this thing without his, I would say, information. Then when he was there in the market coming back, so he was approached by an ex-neighbor. She got out of her car and she then broke the news to him that you have been awarded Nobel Prize for your findings. Then also he was not coming in the limelight. He did not want to come in the limelight. He was away from the media attention and all. So such was the kind of person Mr. Peter Higgs was, and who dedicated all his life in finding this particle. Actually, he published 12 research papers on this particle, and no other work was published by him. So this clearly highlights the fact that how dedicated he was for finding this particle. Now, when was this particle found? This particle was found in 2012, but it was predicted in the 1960s itself that there is this kind of particle which gives weight to the other particles of at the subatomic level. So this is any particle you have. Inside the particle you have molecules. Inside the molecules you have atoms. Inside the atoms you have these particles. These are called as subatomic particles. So we will see what kind of particles are there within the atoms. So its existence was predicted in 1960s, but it was only found in 2012. There was a machine installed. That machine was called as the Large Hadron Collider on the border of France and Switzerland. It was the world's biggest and most expensive machine till then to find out this small particle. Actually, finding of this small particle was very, very important because it would have completed the standard model of elementary particles. Now, what is the standard model of elementary particles? See, we will understand this in this format. Like, this is an atom. Inside the atom, there are multiple types of other particles. These are called as subatomic particles. Fermions and bosons. Inside fermions, there are quarks and leptons. Inside bosons, there are gauge bosons and there are scalar bosons. So these many elements are there inside the atom also. All these elements were discovered. We knew about them, but we were not aware about this Higgs boson. It was only in 2012 where this was scientifically proven that this is there. Till then, a lot of, I would say, things were pending because, this Higgs boson's significance is what you know, that it gives mass to every subatomic, not every, but those subatomic particles which come in interaction with this Higgs boson field, they gain mass. The more they interact, the more mass they gain with this Higgs boson. This is the significance of this Higgs boson. And elementary particles like electrons, quarks, photons, or neutrinos, the Higgs boson is known to impart mass to every other particle. The discovery of Higgs boson is completed what is known as the standard model of particle physics. This model was incomplete because we did not have much information about Higgs. But in 2012, we got to the complete information about Higgs, and hence this standard model of elementary physics was complete. Now we knew about every element over here. See, this is the electron, this is neutrino over here, this is photon, this is Higgs, then there is Z boson, W boson, and all. So these kind of things are there. But now we should also understand that what are fermions and what are bosons. Bosons, it has multiple sub elements in them, but boson is the name given to the family of elementary particles that are known to be carriers of fundamental forces like electromagnetism. Means all the particles under boson, whether it be gauge boson or scalar boson, will be having that fundamental force of electromagnetism in them. Photon, which carries the electromagnetic force, is a boson. Whereas on the other hand, fermions, they do not have that fundamental force, electromagnetism in them. Okay, and they belong to the class called fermions. Basically, the magnetism is of the degree, it is not a complete integer. The degree of magnetism will be 1/2, 3/2, 5/2, like this. But here the magnetism will be incomplete integer 1, 2, 3, 4. That is why we are saying that electromagnetism is present over here, and since they are not a complete integer or whole integer, electromagnetism is not present over here. This is the difference between fermions and bosons. This we should know as aspirants. Now, why it is named as God particle? This is also very interesting because Higgs boson, named after Peter Higgs, understandable. But why God particle? Name of our topic is God particle only, no? So that also should be known. So much of the hype of this Higgs boson is basically, was due to the fact that since 1960s, we knew that something like Higgs boson is there, but the scientists were not able to scientifically prove it or find it. They were only able to do it in 2012. So this frustrated the scientists also. This increased anxiousness of among the scientists also. And, they had their theories, but the theories have to be proven experimentally. That experiment was carried out in 2012 and it was a successful experiment. Now, in the 1990s, there was another Nobel winning physicist named as Leon Lederman. He wrote a book, and in that book, he mentioned about this particular particle, and he wanted to name that book as goddamn particle because, goddamn, this was not getting found or this was not experimentally getting proved. But the publishers said that goddamn particle nahi, God particle, we should name it, and hence the title of the book was God particle, and this is what it is used. So he wanted to name it as goddamn particle, but it was finally named as God particle, and it is used till date, God particle. Now, significance of Higgs boson. This is very important. The big significance of Higgs boson is that the particle is supposed to account for the mass of every other fundamental particle. Means every other fundamental particle, as we saw in that table, these particles, whenever they interact with this Higgs, they will gain weight. They do not have their weight as such. The intrinsic weight is not there in any of these. Even in Higgs, weight is not there. But, the more they interact with the Higgs particle, they will gain weight. It is like this. And it is not like every, particle or every sub-elementary particle is interacting. We'll see. So the significance of Higgs boson is that it is the particle that is supposed to account for the mass of every other fundamental particle. It gives mass to the other particles. Isn't mass intrinsic to matter? Basically, mass is not something that is intrinsic to matter. Mass is not there in these subatomic elements. Fundamental particles of matter like electrons or protons do not have mass within themselves. It is their interaction with the Higgs boson which provides them mass. So in the 1950s and 60s, when the standard model was being developed, scientists realized that equations did not work if these particles had inherent mass. So there were many equations which were formulated by the scientists, and those equations were proved wrong if those scientists accounted for masses of these subatomic particles like protons or neutrons or whatever subatomic particles were. If weights were assigned to them, then those equations proved wrong. So weights had not to assign to them. It was clear that weights are not there in them. Then only those equations will be correct, and those equations had to be correct. So it was a mathematical problem that Higgs and several other scientists worked upon. So Peter Higgs' contribution, basically, it was mainly due to the fact that he alone postulated that this mathematical construct, if it indeed was physical reality, would give rise to a particle, the eventual Higgs boson. Many scientists said that there is kind of a field, kind of an electromagnetic field which is there present in the atom, and when these particles, subatomic particles like the proton or electron, XYZ, multiple particles were there, when they come in interaction with that field, then mass is gained. So this was basically many scientists saying this, that let's suppose this is electron. This is there in this large circle is the, so scientists said that there is a field which is there inside the atom, and whenever this electron comes in contact with this field, this will gain mass. What Peter Higgs said was, see, he said clearly that this field is there, no doubt about the fact, but there is another subatomic element which is generating this field. And that subatomic element is God particle, which was called as God particle, or which we know as Higgs boson. Field cannot be generated like that only. There has to be some particle which will be generating that field. So this is what Peter Higgs had been advocating, and this is what was proved in that experiment in 2012. As it became clear later, it is the interaction of these particles with this Higgs field, the way they change the field or get changed by them, that lends them the mass. Greater the interaction, larger is the mass. Different particles interact with this field in different ways, and that is what gives them different masses. A photon, for example, is a light particle. Light means it emits light. Lights are coming from photons. Does not interact with this field, and since it does not interact with this field, it is massless. It does not have any mass. There are other particles that are massless as well, but particles like electrons or protons do interact and have masses. The Higgs boson itself interacts with this field and thus has mass. Means this Higgs boson, this particle itself interacts with the field and gains mass. So this is the Higgs boson particle, the yellow one which I have drawn. So it interacts with this field and it gains mass. But a photon does not interact, so it is massless. So whichever subatomic particle will interact with this field will gain mass. This is as simple as that. So this is what the findings of Peter Higgs was, and that is why he was awarded a Nobel Prize in Physics in 2013 along with another scientist. You and I would say a homework, you can say, have to find out the name of the other scientist also, along with whom Peter Higgs was awarded this Nobel Prize in Physics in 2013. Now the MCQs, there are two MCQs on this topic. First is, which of the following statements are correct? Higgs boson is massless. The interaction of other elementary particles with Higgs boson provides mass to those particles. The mass of elementary particle is directly proportional to the degree of interaction. Very carefully answer these, see these statements and then answer. Very carefully. Okay. So your fundamentals are going to be tested over here. This is the biggest hint I could have given you. Now, which of these fundamental particles is part of the boson family? Photon, electron, proton, neutron. Out of these, you have to find out which of these is part of the boson family. There were two families in that image which I showed you, the standard model of elementary particle, the fermions and the bosons. So you have to identify that which one is part of this. And with this, we come to an end of today's session. I will be meeting you tomorrow now with more such informative news pieces. Till then, you guys very well know what to do. Not repeating it today. Namaste. Jai Hind.